Mai avem o singură prezentare până la pauza de... Cafea, cine a zis? Avem nevoie de cafea? Da. Și mai urmează ulterior, adică mai avem încă o prezentare de oră. Haideți că ne înviorăm. Aș putea să fac exerciții cu voi, dar nu știu dacă o să mă mai iubiți după aia. Bun, până se pregătește Robert, am să-l prezint. Robert Mezaros, un dezvoltator cu experiență de la o agenție WordPress VIP, specializată în soluții de nivel Enterprise, cu o bogată experiență în freelancing și expertiză în selecția partenerilor. Robert a construit colaborări impactante cu agenții creative. Astăzi, el va aborda topicul Practical Use of AI in Playwright E2E tests, oferind perspective despre eficiența fluxurilor de testare cu ajutorul inteligenței artificiale. În aplauzele noastre, Róbert Mezaros.
Merci. So, first of all, I want to thank everyone who participated in making this event possible. It's truly great. My name is Róbert Mezaros, and I'm here to talk about one specific way AI can help with end-to-end test. We will proceed as follows. First, we will talk about the reason to introduce end-to-end test if you do not have that. Then we will talk about the challenge that end-to-end test poses. We will try to solve that challenge using AI to make our tests more resilient, adaptable. And then we will see what benefits that brings, what are the trade-offs, and what kind of options are available today to implement it. And as a bonus at the end, we will look at do-it-yourself approach, how to implement AI with end-to-end test without using any libraries. So one good reason or one compelling argument to have end-to-end test or test in general is to have some knowledge about the state of the system. Because without any test, as the system evolves, new features are added, we just kind of like lost track, or we do not know that the previous features developed still works as we expect them to do. So let's take this request demo as an example. How can we know without any test if this works or not? We can only know if somebody uses it. But maybe until somebody discovers that there's some kind of problem with it, or at least they suspect there's a problem with it, there's the chance that we lose data. So we lose the request coming in, which means lost opportunity for the business itself. Oh, we don't have slides. Well, this was pretty funny. So this is the form that I was talking about. And so we get this suspicion that this form might not work. So we can look into logs and in some kind of monitoring to figure it out if when this stopped working. And next to it, we can also test it ourselves. So we can just go to the request demo page, fill in the inputs, and submit the form. Then we have to validate our expectations. So in this case, let's say we were expecting to get like a thank you message, and we did that. But then we were expecting data to appear in some kind of third party, and we do not see that. So clearly something is wrong. So after fixing this, ideally we should ensure this never happens again. And this is practically where end-to-end testing or just testings come into play. Ideally, when we are introducing first end-to-end testing, we should only focus on the critical features. We should not use it as a replacement for other types of tests if we do not have those. And we should really focus only on components where there's like integration between UI, database, third-party services, and so on, just like in the example that we looked at with the request demo form. So once we introduce this, obviously we will get some immediate benefit. We will know what's the state of the system, the problem that we just discussed it. Because this is automated, we can execute it anytime, as often as needed, multiple times a day, or relate to some kind of deployment process. We get immediate feedback, and so on. To have this end-to-end test, or the tool to use today, which is the most reliable and probably the most popular, is called Playwright. It's also the tool adopted by WordPress recently. So this is how the end-to-end test could look like. This is practically only just a few lines of code to test most of the integration. The part with the third party, I left it out to keep it a bit simple. So we can see it's quite easy to get started with it. It has a very friendly API. It also offers a UI mode, which makes it very easy to visualize all the steps that the test takes, and we can see side by side practically the code and what kind of effect it produces. So in this case, it selects the input and fills it with a value. So that's great, we get the benefits, but there are also some kind of trade-offs. And one of the trade-offs with end-to-end test is that it comes with some kind of maintainability problems. And the reason for this is end-to-end test is very close to the implementation, meaning that any change in the UI can make our test break or become obsolete. So some example, one is a trivial one, where simply the label was renamed from business email to what's your business email. So in our code, we use the locator where we use the specific string. So in this case, we can just change the string, or possibly to make it more flexible, we can switch to another type of locator. For example, some kind of class-based locator. That sometimes brings some benefits, but it's not always an option. Especially, let's say the form is coming from third-party widget. That class is not reliable, it can change anytime. So another example would be introducing another required field. And here we really look like we are forced to do some kind of update in our test, because otherwise we do not have any way to select that input and fill it with a value. It's a required field, otherwise we cannot submit the form. This is just a simple example with one test, but if you're imagining 10 or hundreds of tests with very different cases, this actually can become a bottleneck. And if you do not have any strategy behind this, how we write the test, many people arrive to the conclusion that end-to-end test, it's not worth it, and they just abandon all the work put into this. So ideally, we would like to get into a state where we avoid this maintainability problem altogether. And this is where AI can come into place. And if you're thinking about the manual testing process for a moment, there's two examples, the changing of the label and introducing another required field. For the manual testing is not a problem, because a tester can just figure it out that the label was changed, and they can figure it out what kind of value they need to provide for the new required field. So ideally, this is what's missing from the end-to-end test code, which is very rigid. We would like some kind of human-like reasoning to make our test adaptable. So one thing we can do first is no longer use locators. We can switch to some kind of prompt-based locators where we just say with natural language, what do we want to select? So in this case, the function is called run, and it can be called anything. And with this change, we already have the flexibility to completely alter the form implementation. So the label can change, the classes can change, even the system that we use can change. Because as long as there's enough contextual information for the AI to figure out what kind of input that is, what kind of input we want, it can just do that. We can take one step further, and instead of just using for the locator, we can just use to drive the entire step. So we just use natural language to drive the entire action. And this is very interesting because we see the disappearance or Playwright API altogether. And we can have even more abstraction on top of this, where we do not even have to call the run functions. We could just have some kind of text file where we just give the prompt. So this is some kind of intermediary step where I replaced all the actions with prompt. But we can take it even further. We can replace a sequence of actions with one prompt where we just give some kind of general instruction. So in this case, we are saying, fill out all fields which are required. So this is going to solve the problem that we discussed with the new required field being introduced. So we have complete flexibility if a new input is added or something is removed. Of course, if we need a specific format, for example, for the phone number, we can just make the prompt a bit more specific. And the last part was the assertion where we relied on a subset of a string. We can also get rid of that and say anything that seems like a thank you message and that's visible is going to be okay. And because this is an assertion, we can form it in a question, because this is really, we are asking what's the state at that point of our test. And here's a possible final version could look like. It's very readable. We just want to get to the request demo page. We want to fill the inputs, and we want to check if we have a thank you message. And we can keep the third-party integration code, which is not visible as was. We don't have to replace everything with a prompt, only the parts that we are interested in it. What's important to realize that if you look at the UI mode once again, it's still the same Playwright code that is executed. Now they are grouped under prompt, but nothing really changes when we look at the UI mode. What is very different, though, is if you look at the source part. So what we are seeing are variables. So we do not have a specific locator in our test code. We are not calling a specific API method. We just have variables. And all of those information are provided by the AI. So we have a really interesting interplay and interconnection between our code and the AI itself. So let's look at a different example to step away from the form. Here is like testing a discount code for like an e-commerce. So this is actually the essence that we are interested in, and what is most important to us is to just go to any product, assuming we can only add products from their detail page, then adding that product, somehow arriving to the cart, then using a specific discount code, and then checking the price difference between the total and subtotal, and calculate that the difference is 50%. All the rest, how the element is selected, what kind of methods are used from the Playwright API, are just things, or just details, or things that could cause problems for us, things that could become broken because something changes in our system. And we do not even know if this is WooCommerce or Easy Digital Downloads or even Magento. We can swap the entire e-commerce, but if we implement the same thing, so the requirements remain the same, we do not have to update our test code. So is this a silver bullet? Probably not, but it definitely reduces the burden of maintenance. And if we reduce this maintenance problem, we can write more tests. We can cover the system better. Or we can just simply shift the resources. People, instead of doing manual testing, they can do exploratory testing, which is more important and more valuable. And what's also important to realize that we can just take this and integrate it into existing system. We do not have to throw away whatever we had before. We can just apply it selectively where we think we need some kind of adaptability. And what is also important, but from a different topic, that we can have contributions from people who are not technical or who do not know the Playwright API, but they can express their intent using natural language. Of course, there are trade-offs and things to be aware of. For example, security and privacy. If you're dealing with a website which is behind login, or they have customer data. We have to make sure that we do not send any sensitive data to possible third-party models. Latency is also a big thing. If you're using this approach, the request-response cycle, so practically talking to the AI, takes time, and we would have our test so much slower. And there are some other problems. Token limits cost all kinds of things. But these also have solutions. For example, local model can solve the problem of the privacy because we control the model. It can also help with the latency, especially if we deploy it together with some kind of continuous integration. They are practically at the same server, so the communication is super fast. Or we can use other techniques like data masking, again, to protect sensitive information. We can do some pre-processing before sending any data to some kind of third party. So what options exist today? So there are some open source library. I do not want to endorse anything. You can just search Playwright end-to-end test AI, and the options will show up. So open source libraries where we can pay with paid models. So practically you're paying for, let's say, some kind of open AI API. Or there are other solutions dedicated where you're paying for that solution instead of like a generic model, and they offer their own libraries. And probably the most interesting, if we just build it ourselves. And I just want the high-level overview to kind of like demystify how this works when we call this run function. So the first thing that has to happen is we have to send a request to the large language model. This has to contain messages and tools. The messages are practically prompts. So we need first like a system prompt where we just prepare the LLM that we are dealing with some kind of end-to-end test with Playwright. We can set some kind of constraints. We tell them how we want to perform certain tasks. And we also have to send the HTML so they can figure out, for example, the locators. And then we can send another prompt, which is practically the task. So this is what we are putting into the run function. Next, the tools. The tools are practically functions that exist in our code. And we let the LLM know about these functions because we want to delegate the decision to the LLM. So they decide, the LLM decides which function should be called. So we are not going to write some kind of complicated conditions. The LLM is responsible for the decision. So this is how the function definition looks like. It has the name of the function, some kind of descriptions. We also say what kind of properties it accepts and which are the required ones. And if we need them, we can also list the options that they should pick, or the LLM should pick. And this is the one for the other one, for the assertion. What's important for the description is to make it easy for the LLM to distinguish between the functions. So in this case, the clue for the LLM was that all assertions take the form of a question mark. So once we set the request, we do get back responses. So for this specific prompt, we see that the LLM identified that we should call the Playwright action function, and it also provided the set of the arguments. So this is the one for the assertion. So it's in the form of a question mark, so it was easy to determine the function. If the prompt is about a sequence of actions, we should expect to get back multiple responses and not one response. The function could be the same, but the arguments will differ. So in this case, we see that the methods are completely different. But there could be other non-tool related responses. So these are mostly for our information that the LLM finished something to do, or this could be error messages. So we can either log them or we can throw some kind of error, practically fail the test. And the last part of the puzzle is the responsibility to map the responses to some kind of code that we have to execute. So we are seeing here that we are taking the arguments and all we have to do is practically replace them in the variables, and then we will get the final code that is executed. And this is the one for the assertion. Again, the same thing, but it looks a bit different, but it's the same concept with the variables and the replacement. So kind of like to recap a bit, first we have to send a request with the prompt and the definition of the functions. The LLM will take a decision. It will decide what functions should be called. Then it will let us know through a response their decision. And the last bit is we execute the code by mapping the response to some kind of code. So this technique called function calling, which is pretty much available in all large language models, is not specific to end-to-end tests. It's broadly applicable to all kinds of use cases, and it's a highly effective solution to get started with. And this is the end of the presentation. I hope it was beneficial in any kind of way. Thanks a lot. Oh, I was on time.
Oare unde a dispărut moderatorul? Ia fi atent că am ajuns. Știți de unde vin? No. Ia ghiciți de unde vin. Am zis să ies primul ca să vă încurajez. Mulțumim frumos. În primul rând trebuie să-ți ofer o sticlă de vin extraordinară din partea sponsorului, dar am zis să pregătesc recuzita pentru, pentru colegi. Haideți să facem o poză. Dacă tot am poză cu toată lumea, ar fi păcat să n-am și cu tine. Cu drag. Așadar, oameni dragi, v-am luat-o înainte ca să vă ofticați, așa că vă invit pentru 30 de minute la o pauză de cafea. Ne vedem în 30 de minute. Mulțumim!